Okay, we're going to try this trickier simultaneous equations now. So what we have here is we've got some nasty fractions involved. But the good news is, of course, that these are equations, and you can always manipulate the equation however you want, and as long as you do the same thing to everything in the equation, you'll keep everything equivalent. So straight away, what I'm going to do is change the way this one looks. All right, I don't want to have to deal with this fraction. So if I've got to divide by 2, the way I get rid of it is to multiply by 2. And of course, if I want to multiply that term by 2, I've got to multiply the whole line by 2. So that's exactly what I'm going to do. I'm going to multiply everything by 2. That will be multiplied by 2. That will be multiplied by 2, that will be multiplied by 2, and of course the 40 will be multiplied by 2 as well. Okay, so that makes it easier to see that the 2 will then cancel with the 2 there to give me 5x. 2 times y will give you 2y, and 2 times 10z will give you 20z, and 40 times 2 will give you 80. So doubling everything in that equation gives me a much nicer equation to work with. So likewise down here, I have another fraction that I don't want, and again I have a 2 as a denominator, so the best way to get rid of that divide by 2 is to multiply by 2. And of course, if I want to multiply that term by 2, I'm going to want to multiply every single term by 2. Okay, so the whole line needs to be multiplied by 2. So that one would then give me 2 times 2x is 4x. That 2 cancels with that 2 to give a 1y. 2 times 4z is 8z, and 21 times 2 is 42. Okay, and this one is fine as it is, so x plus y plus z equals 16. Now this is much nicer to deal with. Okay, so before I ask you to pause the video and set off on this one, let's take a look and make a decision on which variable we're going to first eliminate. So looking at the x's, the y's, and the z's, I definitely feel it's going to be much easier to work with eliminating the y's the way they're already set up. Okay, right, pause the video and see how you get on with this one. Okay, so I'm going to take these 2. You could, of course, gone with the first and the last, if you like, because they're set up quite nicely. It doesn't matter which 2 equations you take, as long as you take a different 2 the second time and eliminate the same variable. But I'm going to go with the first 2 like I have done in the previous examples. So, looking at here, I have y and 2y. Ideally, I would want that to be a minus 2y in order for those to cancel. So I'm going to multiply the top line by minus 2 in order to make that happen. So minus 2 times x is minus 2x, minus 2 times y is minus 2y, minus 2 times z is minus 2z, and minus 2 times 16 is minus 32. And then on the bottom line, I have, of course, 5x plus 2y plus 20z equals 80. And adding these together, minus 2x plus 5x is 3x, minus 2y plus 2y cancels, minus 2z plus 20z is 18z, and of course minus 32 plus 80 is 48. So there is my first equation that I will then use. Okay, so now I'm going to take these 2. And again, in order for these to cancel, I would want a minus 2y down here. So I'm going to multiply the second line by a minus 2 this time. Okay, so the top line will be the same, of course, 5x plus 2y plus 20z equals 80. Multiplying by minus 2 here, I have minus 8x minus 2y minus 16z equals minus 84. Adding these together, 5x minus 8x is minus 3x, 2y minus 2y is nothing, 20z minus 16z is a positive 4z, and 80 minus 84 is minus 4. So that's my second equation. Okay, now so do I have two equations, two unknowns. So 3x plus 18z equals 48 and minus 3x plus 4z equals minus 4. And as it happens, this is already set up really nicely to cancel, so I can go straight to adding these together. 3x minus 3x is 0. 18z plus 4z is of course 22z, and 48 minus 4 is 44. So divide both sides by 22, and of course I get z is equal to 2. And there's my first solution. Subbing that back in then to one of my original, and I'm going to go with the bottom one just because it's nice, easier numbers than this. So I have z, make that clear, z equals 2, and I'm subbing it into minus 3x plus 4z equals minus 4. So instead of z, I'm going to sub in 2. And I end up with minus 3x plus 4 times 2 is 8 equals minus 4. So then I'm going to take 8 from both sides, and I get minus 3x still equals minus 12. Divide both sides by minus 3, and I get, of course, x is equal to a positive 4. And that's my second solution. Now I've got two solutions. Go back to one of the originals back here and sub it in. So I'm going to go back to the top one, is the easiest one again. These, of course, if you didn't want to use the top one for some reason, again, you probably wouldn't want to go back to the fractional ones. So just one of these ones would still work. One of these manipulated ones would still work once you have it, of course, manipulated accurately. But the top one is perfect. It's the easiest one anyway. So that's exactly what I'm going to use here. So the original x plus y plus z equals 16. And I'm going to sub in z is equal to 2 and x is equal to 4. So x is 4, z is 2. 4 add 2, of course, tidy up that is, of course, 6. And then take away 6 from both sides. And I have y is equal to 10. So your three solutions here is z equals 2, x equals 4, and y is equal to 10.